Hello everyone, myself Dr. Monika Bansal, Assistant Professor, Department of Chemistry at Khalsa College, Patiala. Today I am going to discuss three-membered heterocyclic compound with nitrogen. First is the general introduction about aziridine. The another name of this compound is the azacyclopropane. That is, it is a cyclopropane, but one carbon of this cyclopropane is replaced with nitrogen. So the name of this compound is azacyclopropane. Similarly, the another name of this compound is ethylene imine. It is a saturated three-membered heterocyclic compound with two carbon and one nitrogen atom. This compound is used in textile, plastic and coating industries. And this compound shows toxic effects on our body like irritation to eyes, skin and internal inflammation. So direct contact should be avoided. It is very important for the commercial and industrial purpose as it is used in textile, plastic and coating industries. And it is extremely reactive alkylating. Now the one compound which contains the aziridine ring, that is the mitomycin C. This is the structure of mitomycin C. It contains this three-membered ring system, that is the carbon carbon and the third one is a nitrogen. It is a saturated three-membered ring system containing nitrogen as a heteroatom, that is the aziridine. So this mitomycin C act as an antibiotic extracted from a microorganism and used in the treatment of stomach, breast and esophageal cancer. Similarly, the another compound, that is the thiotapa, it is again used for the treatment of cancer. In this case, there are three aziridine rings present in thiotapa. This is the biological importance of this compound. Afterwards, the structure of aziridine. The structure of aziridine comes from the microwave spectroscopy. Its ring is planar and rigid. As in cyclopropane, the bond angle is nearly equal to 60 degree. For example, carbon-carbon nitrogen bond is 59.6 degree. Similarly, carbon-nitrogen carbon is 60.2 degree. That is very close to the 60 degree. And its open chain counterpart, that is the dimethylamine, where the bond angle is 113 degree. So this due to the ring form, it is highly strained molecule, that is with 60 degree angle. The bond distance in this case is 1.48 angstrom, which is smaller in comparison to the carbon-carbon single bond, which is 1.54 angstrom. It shows that is the bond is between sp2 and sp3 hybridization. The ring strain in aziridine is 14 kilocalories per mole, which is greater in comparison to the oxirane as well as with thyrine. For oxirane, the value is 13 kilocalories per mole. For the thyrine, the value is 9 kilocalories per mole. Due to high ring strain, it is the least stable out of these two compounds. Now the physical properties related to the aziridine. It is a colorless liquid and its smell, due to the presence of this nitrogen, the smell is ammonical smell. Boiling point at 56 degrees centigrade, miscible with water, and it show dipolar character. Dipolar in nature, that is 2.09 to 2.40 debye. Because of electronegativity difference, this nitrogen acquires negative and the other side carbon acquires positive. So there is developed a dipole. Due to the presence of nitrogen, for example in this case dimethylamine, it is basic in character as we studied in earlier classes because of the presence of this lone pair of electrons on nitrogen. But in comparison to its open chain counterpart, aziridine is less basic, weakly basic compound, we can say weakly basic compound. And the reason for less basic is due to the delocalization of this lone pair of electrons on nitrogen over the ring system. So this electron pair is less available for the incoming acidic moiety. Now the effect of substituents on the basic character of aziridine ring. When some electron releasing group is attached to the aziridine ring, for example methyl group, which is an electron donating group, so a basic character increases. But when we attach any electron withdrawing group like the nitro group, then it decreases its basic character. Now is the inversions in aziridine. When we attach nitrogen with three different groups, that is R1, R2 and R3, and the fourth one is the lone pair. If there is lone pair, then R1, R2, R3. Now this nitrogen is chiral in nature, as the carbon when is attached to the four different groups is chiral in nature. Similarly, in this case nitrogen is chiral in nature because it is attached to these three different groups, 1, 2, 3, and the fourth one is a lone pair. When it is chiral, so it shows the optical activity. Optical activity, then it exists in the two enantiomeric forms, which is if separated from each other should exhibit optical activity. But such enantiomers have not been isolated for the simple amines. For simple amines, these enantiomers cannot be, because the amines exist like this one. These two forms are rapidly interconverted. This is one form, this is the second, this is interconvertible. So the activation energy between these two enantiomers is very low. That is, it is too small for resolution because of rapid nitrogen inversion. This is the inversion of this amine group. Compare this inversion with aziridine. Now in aziridine, this nitrogen is not free, it is a part of the ring system, and when some substituents are attached to this nitrogen, now this substituent is not in the same plane as that of this ring system. This is above, below, anywhere. So it results in increase in activation energy for the resolution. Now this is the increase in activation energy. So as compared to open chain amine, aziridine undergoes racemization slowly. There is racemization slowly because here nitrogen atom is the part of the ring. This is about the general introduction, structure and the physical properties of aziridine. Thank you very much.